This video explains the n+1 query problem in PostgreSQL. The n+1 problem happens when you fetch a list with one query, then fetch related data with n additional queries. The first query grabs 10 posts. Then you execute 10 separate queries to get each post's author. This pattern is inefficient. Each database round trip adds latency. You execute 11 queries when one would work. The cost scales linearly with the number of records. The solution is to use a join. This query retrieves posts and authors in one round trip. Let me walk through each part. The select clause specifies which columns to return. We grab post ID, post title, post user ID, and username from the users table. The from clause specifies the primary table. We iterate over posts as the left side of the join. The join clause brings in the users table as the right side. The on condition specifies how rows match. Here, we match when the user ID in the posts table equals the ID in the users table. The limit clause restricts the result to 10 rows. This is an inner join by default. Only posts with matching users appear in the result. Posts without a valid user ID are excluded. The key takeaway is this: when you need related data, use a join. Do not fetch relations in a loop. Here is another example. You want posts with their comments. The code above fetches posts, then loops through each post to fetch comments. This creates the n+1 problem again. Use aliases to prevent naming conflicts. Both tables have an ID column. We alias them as comment ID and comment content. This query fetches posts 1 through 10 and includes all their comments. The left join ensures posts without comments still appear. If you only need the count, use an aggregate function. We group by post ID and title. This collapses duplicate post rows into one. The count function sums the number of comments per post. The left join includes posts with 0 comments. The limit returns the first 10 rows. Let me show a more complex example. You want to display 20 recent orders with customer name and item count. Here is the breakdown. We select order ID to identify each order. Total shows the order amount. Customer name identifies who placed it. Item count aggregates the number of items per order. We use an inner join for customers. This excludes any orders without a valid customer ID. Every order must have a customer. We use a left join for order items. This includes orders even if they have 0 items. Empty orders still appear in the result. The group by clause collapses duplicate order rows. PostgreSQL requires all non-aggregated columns in the select to appear in group by. That is why we include order ID, total, and customer name. Recent means newest first. Higher ID values represent newer records. We order by ID descending to get the most recent orders at the top.